learned everything in this section in Algebra 2 and in Pre-Calculus. So you've seen this twice already. Okay? I hope so. All right, so we start with basically the graph of the natural log. So they start by saying we know how to graph the exponential piece, and the inverse of the exponential piece, e to the x, is the natural log of x. Okay, so this is your inverse. Okay, so here is your function. So here's points that you're going to want to write down, little pieces. Okay, there's a vertical asymptote. Where's the vertical asymptote on a logarithmic function? I'll draw it. At 0. At, whoops, not y, x. This is vertical. At x equals 0. Okay, you can find the reference point. Brooks and Doug, I need you guys to quit talking, please. I'm teaching, thanks. Okay, so the reference point is always going to be 1 unit to the right. Okay, and I've taught that before. Hey, guys, I asked you to be quiet. If you can't be quiet, then I'm going to ask you to leave. Thank you. Okay, so it's very simple. You can also find this ordered pair that they give to us as E1. Okay, so that point is going to be somewhere, let's see. So E is, remember, 2.718. So it's about right there-ish. Okay, so, but I really want you to know where that reference point is. Okay, so basically the only way to move the reference point is to take the function and either move it left or right or up or down. Okay, so we'll go over a little bit of those a little later. Okay, so here are some key pieces to this. I'm not going to go over all of this because I think that this is kind of straightforward to you. Okay, so let's do example number 1. So it says, use a calculator to graph the natural log of x. Okay, so go ahead and draw the natural log of x on your calculator. And then also draw the log of x. And tell me what you see. Yep. Okay, do they look super duper duper similar? Okay, so one is a little bit steeper than the other one, right? They both have vertical asymptotes at x equals 0. They both have the same exact reference point. They both cross at 1. Okay, but they have different, I guess, second points. Okay, so the second point that the log has, so somebody said, log has a base of 10, right? Well, that's important. That's how you can find that second point. Okay, so it comes from the base where I got that 10. So 10, 1 is the second point that's on this line. Okay, so this line is going to be a little bit kind of flatter. Okay, so everybody understand where I can come up with 2 points on this function. Okay. All right, so let's do example number 2. So again, it says, now this time without using a calculator, let's see if we can sketch the absolute value of the function of x minus 2. Okay, so what happens if I have an x minus 2 in parentheses for any function? What direction does it move? Goes to the right 2, exactly. Okay, so we're going to take that logarithmic function that we just drew in the last question and move it to the right 2. So this goes right 2. And I'm just going to draw this as blue at first. Okay, so if I did not have absolute value, it would cross through exactly at 3. That would be my x-intercept. Okay, and then it would also go at, let's see, we have a natural log, so right about, oops, there. Okay. Now, what happens if I have an absolute value? What does that do to my function when I draw it? Whatever is below gets reflected above, exactly. So the absolute value is going to look like, boom, that bottom half is reflected. Okay, so the red function is going to be my absolute value. Uh-oh. Dying. Okay, so this right here, this exponential form to logarithmic form, what's that? Oh, sorry. Write the equation for the graph's asymptote. So what's the blue line, the equation of the dotted blue line that I drew? X equals 2. There you go. Thank you for catching it. Okay, so hopefully this part looks familiar. You guys remember how to convert from exponential to logarithmic and vice versa? If you don't remember, you should write this down. Okay, so, well, it's just written right here. Gosh, here we go. Okay, so the basic form, I think that this one is kind of a little bit more universal, the logarithmic one. So if you have x is equal to a being your base to the x is your exponent, the logarithmic form, or excuse me, the logarithmic form would be the log of base a of x is equal to the y, the exponent. Okay. So for question 3a, all we're doing is converting it between the two forms. What would my logarithmic form be for question number A? Nice, yeah. So the log of base 3 of 81 is equal to 4. Perfect. And you said that just fine, Derek. I just read it the other way. Okay, what about for B, if I have a base of e? Okay, good. So I have a natural log of 1 is equal to 0. Perfect. Okay, what about C? If it's not written, what's the base? 10. So it's 10 to the negative 1 is equal to 0.1. Okay, everybody remember all that stuff?
Wait, why is it 10 to the negative 1?
Because when it's missing a base, it's in a base of 10.
Oh,
Okay. All right, so let's just do a couple little simplifications here. Okay, so for question number A, we have e to the 0 is equal to 1. So what is the natural log of 1 equal to? 0. Good. Okay. For B, if I have e to the 1 equaling e, what is the natural log of e? 1. Okay, and the reason that they're doing this is that hopefully these are like big ideas that you're absorbing. The natural log of 1 equaling 0 is something that you should just kind of remember, and the natural log of e is equal to 1 is something you should remember. Okay, what about C? If we have the natural exponential function of, let's see, we got a natural log of e to the n equaling e to the natural log of n, what does that reduce to? Anybody want to make an educated guess there? On C? Good guess, but no. If the natural log of e is 1, kind of the idea of that is like it cancels itself out. So what's the other piece of information in that equation? The n. Yeah, so this is actually just equivalent to n. Okay, so this is a big one too. We can now use C for the next example 5. Okay, if I have the natural log of e to the square root of 2, what is that equivalent to? The square root of 2. Good. If I have, for b, e to the natural log of 3x, what's that equivalent to? 3x. If I have 10 to the log of 2, what is that the same as? 2. Good. And what if I have a log base 2 of 2 to the x squared? X squared. Good. Okay, so those are nice little properties that will help you out in the long run if you just recognize those. Okay. All right, do you guys remember the 3 properties of logs? Okay, the first one is, okay, take a close look at this because they're going to try to trick you on the assignment. Okay, so take a very close look. So we have a natural log of a times b, and the expanded form of that is the natural log of a plus the natural log of b. Okay, so you guys remember when we did condensed form and expanded form? Remember that? Okay, so this left-hand side on all this is your condensed. And this side right here is your expanded. Okay, we called the first one the product property. Okay, so what did we call the second one? So the second one has the natural log of a divided by b. So what would we call divided? Yeah, quotient. So 2 we called the quotient. Okay, and then anybody remember what the third rule was? When you just simply put the exponent in front of the log? Starts with the p, the power property. Okay, so we're using those 3 rules, and we're going to start with question 6 and just simply expand. Okay, so for a, if I have the natural log of 5 divided by a, what's the expanded form? Perfect. Minus the natural log of 8. Very simple. Okay, what about b? If I have a cube root, what's that the same as? What exponent? 1/3. So that's going to go in the front. Okay. So it's 1/3. And then the natural log. What do I do with the x squared plus 1? Can I separate that and do a product rule on it? Huh? No. You cannot separate a quantity that's after a log. Okay? Try to remember that because they'll try to trick you with that. You can only condense it if there's 2 logs written together. Okay, what if we go the other way and condense into a single log? How would I do 7a? Remember, a minus is like dividing and a plus is like multiplication.
Natural log. X to the 3rd y.
Okay, so I'm going to tell you there's 2 ways you can write this. You can say the natural log of x to the -3rd times y to the 5th. Or what happens if I have a negative exponent? You put it in the bottom. Okay, so this is technically more correct to say y to the 5th over x to the 3rd. And really, that actually makes sense in terms of our properties. Okay, it's technically the product property or the quotient property where you're subtracting. Anything that is subtracted just simply gets put into the denominator. Added goes to the top. Derek, what about b? Okay, so you have the natural log of what? X to the 1/2. Where's the x plus 1 going to go, on the top or the bottom? If there's a plus. Okay. And what about the y? Bottom. So minus goes in the bottom, so y cubed. Since there's a 3 in front. Everybody okay with that one? That one's pretty complicated, although kind of simple at the same time. Okay. All right, so the end of this is just solving. All right, so on this particular equation, it's not my favorite equation because there's technically 2 variables involved, so we're just setting this equation equal to x is what we're doing. So how would I isolate the x?
Add this 6 over.
Good.
Or
Subtract it, yeah. So I have e to the 2x minus 5. Okay, so then I technically have an exponential equation. How do you solve exponential equations if you're looking for the variable and the exponent? You rearrange it, exactly. You rewrite it in terms of a log, so you convert it. So what would my logarithmic form of this be? We have a base of e. So y minus 6, and then it's equal to the exponent piece. Okay. So then, then what would I do to isolate the x? Add the 5, so I have natural log of y minus 6 plus 5 is equal to 2x, and my last step, divided by 2. So I'm going to say x is equal to the natural log of y minus 6 plus 5 on the outside, all divided by 2. So that's isolated. Okay, so just remember, if you're solving an exponential equation, get it as simplified as you can, and then just convert it to logarithmic. Okay, we're going to do the same thing with b. It's given to us in logarithmic form, so we're going to condense it as much as we can and then convert it to exponential. So if I have 2 logs on the left-hand side, what should I do? Okay, good. So condense it. So if I have a minus, what is this going to become? The log of base 2 of what? Good. Okay, so now I'm in logarithmic form. What's my exponential form of this? So we have 2 to the third is equal to x over x minus 8. Okay, at this point it gets a little bit more complicated. How do I solve this if I have an x in the bottom? Nope, they cannot cancel because you got minus in the bottom. Minusing. So you got to multiply the quantity of x minus 8 to the other side. It's like cross multiplication. Okay, so if I multiply that to the other side, by the way, what is 2 cubed? 8. So I'm just going to say that's 8, and I'm going to multiply the quantity to the other side. Okay, then I'm going to distribute the 8. So I have 8x minus 64 is equal to x. Okay, so now I want to get the x's on the same side. So I'm going to do 2 steps in one here. I'm going to subtract the x and add the 64. So if I subtract x, I get 7x's equaling a positive 64. And then what's my last step? Good. So for this one, x is 64/7. Okay. All right. Last thing is the change of base formula. This is kind of an old school formula. Our calculators are more advanced now, so we can almost like forget about it, but it's useful with properties. Okay, so if we have the log of base a of x, that's equivalent to the log of x over the log of a. So notice that they give you a base of b. You can make the log of anything. So like if we were going to do question number 9, you guys see this question, log base 7 of 112. The change of base, I can make the base whatever I want. I could do the log of 59 of 112 over the log base 59 of 7. It doesn't matter what I choose my base to be. I can do anything as long as they're the same base. So the reason you can do anything, or because you can do anything, they like to make this more simple. And instead of using an log log of whatever base you choose, they try to use just a natural log. It just makes it simpler. Less writing by a letter. Okay, so type that in your calculator. Does everybody know how to find the change of base formula on your calculator, and then the like that special button you push so you can see the actual logarithmic form? There we go. So if you hit, so you can either do the natural log of 112. Make sure you end the parenthesis after the 12, divided by the natural log of 7. Or if you hit alpha zoom. No, just kidding. Alpha window. Alpha window number 5 also gets you that notation. So whichever one you prefer, just make sure you can type it in correctly, because it's harder for me. So everybody get 2.4245. 2.425, right? Everybody good with that? Okay, so then they just ask you to do question number 10 using that special little formula. So how would I solve number 10? A, I guess. If it's in exponential form, what do I do? Convert it to logarithmic, so it's my logarithmic form. Log base 3 of 6 is equal to x plus 2. Now, did anybody else notice that it said exact? So can I convert it to a decimal? No, because if you convert it to a decimal, it will not be exact. You will have rounded. So my last step is just to isolate the x and solve for, or subtract the 2. So x is going to be the natural log base 3 of 6 minus 2. So that's the exact value of x. Just leave it in logarithmic form. Okay, so for B, they ask you to find the decimal value of our answer. So can somebody type that in and tell me what that's equivalent to? Okay, good. That's what I got too. Perfect. So good? Everybody remembers all this good stuff? Okay. So you need to do 1 through 24 alls for Wednesday.